Hello everyone. Hope you had a fantastic day yesterday. Well, today we're going to be continuing on from what we did yesterday. So all of this is still the same type of stuff with graphing. We're going to learn just a few new things today to add to it, real simple things, so not anything that you should be too difficult for you to do without me being there. I am expecting you guys to take all of the notes and to complete the homework for today. There is not that much to do. We're only doing the front side of the notes and the front side of the homework, which means in the homework there are only 4 graphs that you need to do. If you did not finish yesterday's homework, you will need to complete that as well and get all of that turned in before you leave class today. All right, there shouldn't be any trouble with the sub. If there is, remember it's an automatic detention, no questions asked. So be on your best behavior, do all your work, work together, try to get things done, try to understand it as you're doing it. We do have a test coming up and you will need to know this stuff for the test. All right, so let's go through these notes. So remember from yesterday, we have exponential growth, where growth is when b is greater than 1. Remember the formula is y equals a times b to the x power. The b, which is usually what's in parentheses, is what determines your growth or decay. So if it's greater than 1, it's going to be a growth. If it, remember, like y equals 3 to the second to the x, that 2 is greater than 1, so it tells you that it's growth. And the graph is going to rapidly increase. This other number here is the a. So this is something new that we're going to talk about. This a is the y-intercept, which means when we are filling in the table, that is where x is equal to 0. And if x is equal to 0, we're only going to have that number left. So in this case, my y-intercept when x is 0 in the table, my y-intercept is going to be 3. Because anything to the 0 power goes to 1, and 3 times 1 is 3. So that number in front, you don't even need to calculate it most of the time. You can find it just by looking for the y-intercept in the front, and that's the a value. Okay, exponential decay. That is where it decreases rapidly and goes very, very close to the x-axis, but it never crosses. Exponential decay is determined by the b value is between 0 and 1. So that's normally a fraction. So for instance, y equals, we could say 3 to the 1/2 x. So this is your decay because it's between 0 and 1. The 3 is still going to be your y-intercept. Okay, so the growth factor is the 1/2, and that's the exponential decay, and the 3 is your y-intercept. So let's try graphing some of these, and then we're going to talk about the domain and range today. And that is the only thing new that you're going to learn besides what we learned yesterday. So we talked about the y-intercept, and we're going to learn about domain and range. So we have our function right here. Our normal x values, if you remember from yesterday, they're always going to be -2, -1, 0, 1, and 2. The y value is your function, so this is going to be 2 to the x power, and wherever x is, we're going to plug that in. So this is going to look like this, 4 times 2, and we're going to put in -2 where the x is. So my exponent is -2. Well, remember from yesterday, 2 to the -2 power, we have to flip that over. So this is going to give us 4 times 1/2 to the second power. Well, what is 1/2 to the second power? That's 4 times 1/4. Well, 4/4, 4/1 times 1/4 is just 1. So the value that I'm going to graph is -2, 1. Okay, let's try it with this one. 4, 2 to the -1 power. That means I'm going to flip it, and I'm going to have 4 times 1 over 2. Well, 4 times 1 over 2 is 4 over 2, which just equals 2. So I'm going to graph -1, 2. 0, that's my y-intercept. So if I go up here, my y-intercept is 4. So I know that this is going to be 4. If I forget, I can do the math, and I have 4 times 2 to the 0 power. Well, I know 2 to the 0 power is 1, so 4 times 1 is 4. 4 times 2 to the 1 power. So 4 times 2 to the first. 2 to the first is just 2, so 4 times 2 is 8. And 4 times 2 squared. 2 squared is 4, so 4 times 4 is 16. So now I can graph each of these. Now, I usually start with the bottom just because it's easily able to be graphed. All of these can be because they're not fractions. But for some reason, I always work from the bottom up. You can work whichever way you want to, with -2, 1, or you could start with 216. In this case, 216 is not even on the graph. It's going to be way above. So we really don't even need to graph that one because it's off the graph. The second one is 1, 8, so we can do that. Go over to 1, up to 8, plot your point. 0, 4, -1, 2, and -2, 1. So I know that this is a growth because my b value is 2, which is greater than 1. So I know that that has to be a growth. So a growth graph is going to look like this, and this one does. It comes down, and it gets very close to the x-axis and goes like that. So it does represent a growth, so I know I'm at least on the right track. Okay, so that we all learned yesterday. The new part is talking about the domain and range. If you can remember this, this will be easy for you, okay? Domain for these is always going to be all real numbers. For every single one of these that we do, all the exponential growth and decay functions, the domain is always all real numbers. Remember, that's the x values, and the x starts here and over here. So this is your x. The horizontal axis is your x-axis. So this arrow means that it's going to continue going in this direction on and on and on forever. So it includes all of those values. And then in this one, it means it's going to continue to just keep going out and out and out and out, and it's going to continue to go in that direction, which means it's going to cover all of the x values, which means it's all real numbers. So for that one, you don't even really need to remember much about it. Just remember domain is always all real numbers for every single problem. So you can write all real numbers, or you can use that capital letter R like we learned before. Or another way that you might see it is from -infinity to infinity. So that's also another way that it can be written. So it can be any of those. Now range is a little bit different. Range, we're talking about the y values. So we're looking at the y-axis here and here. So since the graph never ever crosses the x-axis, my lowest y value is right here at 0. So my y values are going to be when my range is going to be when y is greater than 0, because all of my graph is above this point right here at the x-axis. It's above the x-axis where y is equal to 0. And so since the graph is there, it includes everything above 0. So in this case, if the graph is above the x-axis, it's going to be y is greater than 0. If the graph falls below the y-axis, or the x-axis, it's going to be y is less than 0. Two simple things. You have two choices, either y greater than 0 or y less than 0. So in this case, the graph is all above, so it's going to be y is greater than 0. All right, number 2. Y equals 2 to the 1, or 2 times 1/4 to the x power. So remember, we're going to use -2, -1, 0, 1, and 2. We're going to put the function in. So this is going to be 2 to the 1/4, or 2 times 1/4 raised to the -2 power. So we just have to flip that over and make it a positive. Remember, when we have negative exponents, we flip the fraction and make it a positive exponent. So this is going to be 2 times 4 to the 2nd power, which is 2 times 16, which equals 32. This is going to be 2 times 1/4 to the -1, which is 2 times 4, which is positive 8. I already know that my y-intercept, where x is equal to 0, is 2. So I can automatically fill that in. Again, if you don't remember and you start doing the math, you can. 2 times 1/4 to the 0 power. 1/4 to the 0 is just 1, so 2 times 1 is 2. 2 times 1/4 to the first power is just 2 times 1/4, which equals 2 over 4, which is 1/2. 2 times 1/8 to the second, oops, not 1/8, 1/4. 2 times 1/4 to the 2nd power is 2 times 1 over 4 squared, which is 16, which is going to give me 2 over 16, which is equal to 1/8. Okay, let's graph these. So I'm going to start at the top this time because it has numbers that I can relate to without being fractions yet. So -232 is obviously off of the graph, so we don't need to graph that one. -1/8, go over to -1. Oops, that's the wrong one. Up 8. 0, 2 is right on the y-axis. That's our y-intercept. 1.5. So that is at 1 and right at the half point. And then 2 and 1/8 is going to be really close to the x-axis. So it's going to keep getting closer and closer. Well, we can draw our graph and keep it as close to we can as the x-axis. All right, first of all, let's name if this graph will be exponential growth or decay. Since it's 1/4 right inside the parentheses, that is a fraction between 0 and 1. So this is going to be decay. So this is a decay graph, decay function. The domain is always going to be all real numbers. And the range, since it's above the x-axis, it's going to be y is greater than 0. Okay. Number 3. Now we have a little bit different type of function. My a value is negative. We've only done the positive one, so now we're looking at the negative value. It's not going to change the way we do things. It's only going to change the way the graph looks. So the negative flips it upside down. It's still a growth. It's just a negative growth, and it's upside down graph, and it's going to go on the bottom part of the graph instead of the top. So we're going to take a look and see how that looks. I know that this is growth because of the 3 is greater than 1, so that's a growth function. So now let's see what this is going to look like. -2, -1, 0, 1, and 2. If I have -2, 3 to the -2 power, I'm going to flip that and I'm going to get -2 times 1/9, which is 1/3 squared. That's 1/9. So this is going to be -2/9. -2 times 3 to the -1 power is going to be -2 times 1/3, which is -2/3. 0, I know is going to be my y-intercept, which is -2. -2 times 3 to the first power is just -6. And -2 times 3 to the second power is -18. Now we can graph those. So I'm going to start with the bottom. 2, -18. It goes off the graph, so I can't graph that one. 1, -6. 0, -2. -1 and 2/3, and 2/3 is between 0 and 1, so anywhere in that area. And then -2 and 2/9 is really close to the x-axis, so you can just do it just a tad bit lower than the 2/3, right? And so this one is going to look like this. So it's similar to the one right above it, except it's flipped upside down and it's below the x-axis this time. So our domain is still going to be all real numbers. And the range now is going to be y is less than 0 because it's below the x-axis. So it goes down. The graph is below the x-axis, so it's going to be y is less than 0. All right, it's the last one that we're going to look at today before you start your homework. We know that this is a decay because 1/2 is between 0 and 1. I'm going to fill in my numbers, -2, -1, 0, 1, and 2. And then I'm going to figure out the values, the y values. So -3 times 1/2 to the -2. That means I'm going to flip it and make it positive. It's going to be -3 times 2 squared, which is -3 times 4, and that is -12. -3 times 1/2 to the -1, which is going to be -3 times 2, which is -6. 0 is -3 because that's my y-intercept. -3 times 1/2 to the first is -3/2. And -3 times 1/2 to the second is going to be -3 times 1/4, which is -3/4. All right, so let's graph what we can graph. -2, -12 cannot be graphed. -1, -6 is right here. 0, -3. Now, -3.5 is the same as -1.5. Or -3/2 is the same as -1.5, so we know where that goes on the graph. Sometimes you might have to put it in your calculator and get a decimal so you know where to graph it at. So 1 and -1.5 is about right here. Oops, didn't graph it. All right, and then 2 and -3/4, which is going to be a little less than 1. And then we can draw the graph. It's going to get close to the x-axis, but it's not ever going to cross. So now this is, because it's negative, it's going to be flipped over on the bottom. And since it's negative, the range is going to be y is less than 0. And the domain is always all real numbers. Okay, that's our notes for today. So hopefully you were able to pick up on some of that. Pretty much the same as what we did yesterday. All of the calculations for the table is what we practiced yesterday. And then the only new thing is your domain and range and your y-intercept. That's it for today. So you can get your homework from the sub and start working on those 4 problems. Make sure those get turned in before you leave today. All right, so I will have a great day and I will see you tomorrow.